Hey guys, Harv here, and welcome back to the Kerbal space program. This is the game in which we do amazing things like landing on other planets, and wouldn't it be great if we could do, in one mission, a journey to every single planet, and land something on it, and come back to Kerbin. So that's the premise, basically. I have got a holiday coming up in 2 weeks' time. I'm going to be away for 2 weeks, so I want to desperately try and make some videos so I can continue to provide you with entertainment once every few days. So we're going to start this new series, and it's actually based on something I was asked to do, and I promised I would do quite a while ago. When I hit 10,000 subscribers, I did a competition, and the winner was allowed to choose me a mission. The winner told me to land on every single planet, and I never did. I kind of put it to the side and said, yeah, I'll do it later, stop harassing me, and I never did it. So this is it. This is going to be a series of fairly long videos, live commentary, in order to try and make it take up the longest time, I suppose, just to try and provide you with as much entertainment as possible, because it's much easier to get live commentary videos out quickly. So these are going to be roughly half an hour long until we complete the mission. So I've already got an idea how I'm going to go about this. And we've already built kind of the main bit, which is really going to be our Spacia launch stage. We're going to build everything on top of this because we've already got the launch stage in place. We know this can lift 80 tons worth of package. And with this, we should be able to deliver whatever we want up to orbit, and from then we can carry on doing things. So in order to land something on every planet in one mission, that basically is defined by having one persistent ship for every planet, but doesn't necessarily itself have to be landed on it. If I make a pusher, a central stage, something to take our payloads, so not this stage, this gets everything into orbit, we can ignore this, but if I make a central stage now that can take whatever we want to another planet, and then we can land that payload down on the planet and come back with just the middle stage. It seems like a fairly good idea, and it shouldn't be too difficult. We know that we can get some very efficient engines. We could use a couple of these. We could just put them straight on like that, I suppose, and then we could, I wonder, maybe we'll have to use some equations to actually find out how much delta V these things will give us, and in fact we will do that, but I'd just like to propose a start-off scheme. Probably not going to be this, but it's just something. And we have our capsule. Which one's more heavy? I want to use something this size. This one weighs 4.5, that one weighs 4, so we can use this. Have 3 crewmen. We'll want to give it advanced SAS. And yes, we'll have to delete this probe down here and make sure this is the actual parent body, but we're just designing something now. We'll put that there. And yeah, we can have our lander attached on top via a docking port, I suppose. It's not going to have to come back up, and that will allow us to attach to anything that has a docking port. So this will deliver, this will be put into orbit, we'll dock our payload onto it, we'll deliver it to a planet, we'll come back with just this, and we'll continue from there. It would be nice to put a flag on every planet. Maybe we'll deliver an actual Kerbal. Just have him alone, lonely. I don't know, we'll think about it. But could something like this work? It seems like a lot of fuel for one engine. Then again, that is quite an efficient engine. It will do the job. It definitely will do the job. I don't know, let's take a look. We'll do some equations. We'll use Tsiolkovsky's rocket equation. That's a terrible accent. We'll use Tsiolkovsky's rocket equation, which basically tells us how much change in velocity we'll get from any engine with any amount of fuel. And is this all we need? Do we want this to do the docking, or do we want the payload to do the docking? Because RCS is going to have to go on one of them. Well, just to be safe, we should probably put docking capability on this anyway. Okay, so we're actually at this point going to get rid of this. I'm going to put this here for safekeeping for now, and then take all of this off, take all of this off, delete this, and now we can get our pod. I have to move this, there we go. Okay. So, oh dear, wait, I need to take that, and then, oh, I built it from bottom up, so this stuff isn't going to work. I'm going to have to rebuild that. It's not quite perfect. I haven't got the subassembly mod in yet. I don't know if this will help with that particular task there. Or I don't know whether that would help with this particular task. No, it's alright. I just need to make what I've made again. Except building it top down this time rather than bottom up. So we have advanced SAS. We have a half fuel tank with 3.5 fuel tanks on the sides. Symmetrical, thank you. We have our Nerva rocket motor. There we go. Some fuel lines leading in. That's not going to work. Hang on. Needs to be there. And then down to there. There we go. We'll put some RCS on the top. Is that what we had? And we had a docking port on top, didn't we? We had this. It looks really weird, but it actually looks kind of suitable. Does look fairly suitable for going on long distance journeys. Where's the centre of mass? Right about here, so we can put some reaction control systems in place in order to allow us to maneuver. We'll put centre of mass there, and at the centre of mass over here. That should be okay. 6 to maneuver a fully fueled one of these. Waste of weight, maybe, but I think we're probably going to end up needing it no matter what we do. Okay, now we have this, and we can attach this back on, and there we go. That is our launch stage and our potential pusher system. Okay, so I'm going to put some struts on here. And some struts on, is that symmetrical? Probably there. Oops, there we go. And that should be okay, shouldn't it? Yeah. I know the launch system's built sufficiently. That should be okay. I just need to separate out some of the docking ports. I mean the decouplers. Wait, hang on. The order's been screwed up a little. Where are the decouplers? Are they at the bottom? Yes. This should go first, yes, then that, and then those. So we need a new stage here. There we go. And that might well be that. It might well be. Okay, it's time to do some maths, I think, but we're going to rename this. We're going to call it... How about... Oh, come on, we need a proper name. I need to think of an actual proper name. We're 8 or 9 minutes into the video and I haven't thought of a name for this. No. I can't think of a name for my ship, damn it. I can't remember what I'm going to put. I had an idea, I think, once, a very long time ago, in a galaxy far, far away. For now, we're just going to call it As of Yet Nameless. You guys in the comments of this video, tell me exactly what I should make it. I don't know if this will be uploaded before the next episode comes out, but whatever. Mark 1. God damn, I can't think of a name. Alright, save that. Okay, so what we want to do now is remove our launch stage. This is the system that is what we're going to be having. We remove these struts. This is the final product of our pusher stage in its first iteration, right? You know, not the final thing or anything. There we go. So I'm just going to call this Mark II, even though it's not really Mark II, and launch it. Okay, to the launch pad and proceed. There we go, put this onto the pad so we can get some information about it. And now we're going to use a rocket equation. Now this, for those of you who don't know, this is a way, I was going to do a video on it, but someone else did. I think I might still, because it's not really copying. But yeah, it's just educating you about how you can know. This is a way to find out how far your rocket will be able to go without actually testing it. It's an equation, and the equation says that delta V equals your effective exhaust velocity, which is equal to your specific impulse times by 9.81, or 9.8 that they do for this calculator, just to make it simpler. Your effective exhaust velocity times by the natural logarithm of your initial mass divided by your final mass. And we have all that information. So I'm going to put this into the calculator I've just pulled up. Our ISP for this engine is 800, isn't it? I swear it's 800. I'm going to use 800 for now. I'll go back and actually find out if it is 800. So 800 for our specific impulse, our efficiency. Our initial mass is 44.75 tons. 44.75. It actually does it in kilograms on this scale, but that doesn't matter because it's finding a ratio between the initial and the final. So I can just do 44.75 in tons and the final in tons, and it will still work. So, okay, we've got the initial, we've got our ISP. If we go back to the... yeah, we'll have to add up. We'll have to subtract by how much we lose if we empty all the fuel. Right, first let's check this. ISP in vacuum 800, yes, okay, so ISP is correct. And we need to find our final mass. So these fuel tanks we have on the side here, they weigh 9, and when they are dry, they weigh 1. And because these are the only fuel that we're emptying, we're not going to count RCS as a fuel because it doesn't go through this engine. So we have to subtract 8 for every fuel tank off of our initial mass, right? That should be the only thing changing. Okay, so we have 4 lots of these fuel tanks, which means we're subtracting 32 units of mass from 44.75, which is equal to 12.75. By God, I hope I get none of this wrong. Initial mass 44.75 subtracted by 4 lots of 8, which is 32, equals 12.75. That is correct, I believe. Okay, so now we have that all plugged into our equation. We can calculate the delta V, which equals 9,843.6. That's how much we can change our velocity by. We can change it by 9,843.6 meters per second. Just this craft. This craft itself can do that. Now the difference being that we're actually going to be carrying a payload. So 9,800 blah, 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 that's basically 10,000 meters per second. I know that can take us to every planet and back. Except for maybe Moho. Maybe not Moho. Because Moho actually takes an awful lot to slow down into orbit around. I don't know, we'll see. But we're going to put a little payload on top of our ship here. And we are going to give it a Kerbal. There we go. It's not going to have any advanced SAS. It's going to have a very small tank with some engines so it can deorbit. There we go. 3 of those. Like that. It's going to have some parachutes and some landing legs. Landing legs first. We'll put on 3 of them. Like so. Ah, the guy's not going to be able to get in, is he? Or out, more importantly. Move these. Swap them like that. There we go. Okay, so 3 engines, 3 landing legs with parachutes. Might as well have 3 parachutes, I guess. Does that work? Yep. Not exactly perfectly symmetrical, but it is actually symmetrical. Okay. So 3 parachutes. Is that all we need? We'd like a ladder. If we could put that there and maybe put a ladder here. Is that going to work? I don't know. It might do. Let's move this up onto here. Ah, we can't. Okay. Where are the parachutes going to go? I think that's above the centre of mass, so that's not actually going to work for us. No ladder. Forget the ladder. Ladder's fine. We don't need a ladder. We just need them to be as high up as possible. Oh, come on. Work with me. Work with me here. Ah! That's not going anywhere. It's just being annoying. There we go. Okay, that should be okay. This isn't the actual payload. I don't know why I'm getting so stressed over this. This is just a weight simulation. So without a payload, our pusher thing here could go nearly 10,000 meters per second. 9,800 and something meters per second. I've got the number right here. I'm not going to forget it, don't worry. In fact, let me make a notepad document and let me put this down here. New text document. I'm going to copy in that number in all of its very long decimal places glory. I did round it, by the way, for the sake of not having to read out the entire thing. Okay, and now we have a different issue. So we're still subtracting 32 from our initial mass, but our initial mass has changed because we're carrying a payload. So let's launch this onto the pad. And we'll have a look here. The initial mass is now 47.59. So I'm going to put that into the calculator. 47.59 as our initial mass. And our final mass minus 32 from 47.59 is 15.59. There we go. And now we're going to recalculate our delta V, and we get significantly less. What was... I didn't put the number in, did I? There we go. What was 9,843 now drops down to 8,749. So we can change our velocity by 8,749 meters per second of delta V if we have a payload weighing this much, or massing that much, which is quite a big difference. That's definitely enough to take us to planets like Juno, so we shouldn't have to worry about that. It's just that I was considering working in and then working, like, you know, starting with Moho, and then to Eve, and then to Kerbin, or we're here on Kerbin anyway, and then to Juno, you know, working like that. But I don't know if we're going to have enough to go to Moho. Let's do a quick Google search. Change in velocity required, so, oop, hang on. Delta V, I don't know if this is going to come up with anything. Delta V required to land on Moho. Answered, Moho landing on the forums. How much delta V do you need to transfer, get captured, and land on Moho? Oh dear. Oh, but this is including orbit Kerbin. It says you should be able to do it if you launch with around 10 kilometers per second of delta V. That's what we've got. But hang on, this is still including to get into Kerbin orbit. It says here, this is a post from a guy on the forums. It says there is a 2 kilometers per second ejection burn to get back to Moho. Then you need to slow down using 2 kilometers per second of delta V to get captured, and 1.5 kilometers per second of landing. Now we have that, I think. 1.5 kilometers per second of landing. I don't know if our payload that we currently have designed here has that, but that shouldn't be a problem. So this design may actually work with the 8,000 something meters per second it has by carrying this payload. That should be enough to definitely get the payload at least to where it's going. However, the important part is getting this thing back. I mean, we can always send like a refueling tank, a probe, to give it enough fuel to come back, but that sounds a little bit like cheating. Sounds utterly too complicated anyway. But yeah, that should be okay. I'm going to roll with this design because I think it should work. It should work. Hopefully it'll work. Hopefully. And that should be okay then. How much RCS do we have? 300 units, that's plenty. And we should actually change our position because... Actually no, we're not going to be doing any RCS whilst the payload's attached, are we? We're using it to dock to the payload, not to move the payload around. Okay. So this is our design. I think we've got our pusher plate. The payload will change because we're going to have to work out how much delta V we can put into this little payload. But that should be okay. So we can actually just load back to our as of yet nameless Mark 1, which is a stupid name. I need a proper name. And we will have the exact same ship right here. There we go. So I think that's all is left to do in this mission, unless I've forgotten anything drastic, is just to send this thing up into orbit. We can probably put the payload on it straight away, can't we? This thing can lift 80 tons. That weighed in at 44. Yeah, we can put a payload on it immediately. Okay, so what did the payload weigh just then? We went from something like 44.5. Yeah, we went from 44.75 up to 47.59 tons. So that was an extra... Hey, that was less than 2 tons. That was really not very much, wasn't it? No, that was just over 2 tons. In fact, it was 3 tons. Roughly 3 tons. Because this tank itself weighs 1.125, and we had a command module which weighs 0.8, and it added up. Okay. So we have this. I'm going to make a new thing. So if we can have a payload that weighs around 3 tons. And there's actually a lighter command pod, isn't there? We can use this. This weighs 0.6. Significantly lighter. Okay. And this is what's going to land maybe on Moho. If we start with Moho, this is what's going to land on Moho. We don't have to worry about overheating because that's been taken out now, I believe. But we do have to worry about meters per second of delta V. How much thrust, how much delta V will our payload need to have? Now, in this thread that I just googled literally just now, it said, someone said roughly 1.5 kilometers per second for landing. Sounds reasonable. Does sound reasonable. Does that include deorbiting? Yeah, probably. It must do. So if we aim for roughly 1.5, 1.6, maybe even 2 kilometers per second from this payload, then we should get a fairly good... Hopefully we can put that into a low enough mass. Okay. So we're going to try what we did, except I'm going to use less engines, because more engines, more weight that you're not burning off, so less delta V. Wow, this thing is wide. Okay. Let's put 2 engines on the side. We'll put landing legs. We want to be as light as possible. Are landing legs necessary? If we're going slow enough... Oh, but it's Moho, it doesn't have an atmosphere, so parachutes are useless. Oh dear, okay, we need landing legs. If this is going to Moho, then we aren't going to take anything like that. Okay. Moho. I've never actually legitimately landed on Moho. I know it's a crime, it's a sin in my position, but I haven't. So I'm not familiar with making stages for it. That's slipping inside the command module, that's not good. Oh dear. Okay, well let's give it a full tank then. How much does this weigh? 2 and a... Oh, well, it will give us more delta V. And it'll actually make us able to put landing legs on this thing. And again, only 2 engines. Is that going to be enough to support its weight on Moho? It's fairly low gravity, isn't it? Why isn't this thing working? Really? Why is this not working? There's a shimmering going on over there. This is really odd. What? Come on. God damn it. It's a surface. It's... Are these fuel tanks broken? These aren't new fuel tanks. They shouldn't have been changed. Why? Oh dear. Deary me. Okay, screw that one. We're going to go back to this one. It's... The entire game is broken. Is it the symmetry? Is the symmetry doing it? It may have been the symmetry. Hang on. No, it's still doing the red shimmering thing. Let's try putting these on first. There. And then putting these on. There. See? Perfectly fine. Nothing to worry about. Okay. Now, hopefully, if that is sufficient thrust, how much thrust do we have here? Engine max power is 20. 40 units of thrust. Is that 40 newtons? Is that 40 newtons of lift? I don't know. Probably not. Oh well, let's act as if this will work, and then we may actually do some testing. We'll have to do some calculations later on to see whether that's enough thrust to land. It should be. I have a feeling it won't be though. Maybe we will need 3 engines. But nevertheless, let's have a look at the weight here and let's see how much delta V we have. So this thing weighs 3.18. So our initial mass, we're going to find out the meters per second of this. So 3.18 tons. Okay. The ISP we'll find out in a second. Let's end the flight, go back to the VAB. The ISP of these engines, now having multiple of them doesn't change the efficiency. It just adds more weight. So our ISP is, in vacuum, 300. So down from 800 to 300, quite a big dip. 300, our initial mass is 3.81 tons, and our final mass, after emptying this of fuel, it goes from 2.25 down to a dry mass of 0.25, so minus 2. So down from 3.81 to 1.81. And now our meters per second delta V, yes! We have around 3 kilometers of delta V. 2.9 something kilometers per second of delta V. That's nice. That's very good. I haven't been noting down these numbers. I've been forgetting them. Oh no, hang on. Maybe I haven't. Where are the numbers? I've just been opening a lot of text documents. Okay. I've got our initial thing from that initial payload, from the initial stage without a payload. So let me type that in. Without... Hang on. Without payload... God, I can't type. Without payload is that many meters per second delta V. This is our payload Mark 1 just by itself with 2 engines. That's right, actually, payload Mark 1, 2 engines. And what was our meters per second delta V of the craft with a payload? Well, we'll figure that out now. It was 44.75 plus 3.81 that this payload weighs is 47.93. Something like that. 47.93. I'm probably getting something wrong. Do excuse me if my maths goes wrong. 47.93 initial minus the 32 brings us back down to 15.93, which gives us, carrying this payload, gives us 8,636 meters per second of delta V for our with payload. With payload, okay? there we go. We've worked out a lot of things this episode. We've done a lot of maths, done a lot of calculations, and that is the end of today's recording. So in the next episode, we're going to work out how much delta V we have with 3 engines on this, as opposed to these 2 radial engines. We're going to see if that is enough thrust to land us on Moho, and perhaps we're going to put our pusher stage into orbit, and many things more. Thank you very much for watching. Thank you very much for watching this first episode of To Every Planet and Back in one mission, or whatever this series is going to be called. If you like the idea of this series, if you're going to watch more, then please do like the video so I know that. Thank you very much for watching, and I shall see you all next time.